Here's our homework problem where we have to back engineer and figure out the percentage of progeny based on the total number of progeny is 1,000. The interference between the genes is 0.5. So remember, what is interference? Interference is 1 minus coefficient of coincidence. If I have 0.5 as interference, that means that coefficient of coincidence is 0.5. Remember, what is coefficient of coincidence? Coefficient of coincidence is the ratio of observed double crossovers to expected double crossovers. So if it's half, that means we observed 50% of what we expected. Where am I going to get these observed and expected? I see the map, which gives me 6 and 13. That means what? I would have the 0.06 and 0.13 double crossovers. This would be between B and PR. They nicely already told me that PR is my middle gene. And this is the distance between PR and VG. So then when I multiply these two, I get 0.0078. That multiplied by 1,000 will give me 7.8. That is the double crossovers that I expect, assuming that they are independent. The crossovers between BPR and PRVG, if they are independent, then I should have a probability multiplied by each other, and I get 7.8 progeny, so almost 8, who will be double crossed overs. But the coefficient of coincidence is 0.5, which tells me that I only observed half of that, which will be 3.4. So that means that I only observed half of that. Well, what is half of 7.8? 3.9, almost 4. So I only observed 4 double crossovers. And because this is all theoretical, I'm just going to say 2 and 2 divided by 1,000 in percents gets me 0.2%. So I will get 0.2% in double crossovers. What does 0.6 and 0.13 tell us furthermore? So remember, what is 0.06? All the crossovers between B and PR, including the double crossover, those are the ones that I observed, plus question mark over 1,000 should give me the crossover just between B and PR. By the same token, I would do 0.13. So cross multiply. You end up with 60 minus 4 equals the question mark, and 130 minus 4 equals a question mark. This is the crossover between B and PR, and these are the crossovers between PR and VG. So what is that? 60 minus 4 is 56, 126, and you divide that by 2. So far I got 0.2% and 0.2% for double crossovers. Then I get 2.8% and another 2.8% for crossovers between the first two genes. Then 6.3% and 6.3% as your crossover between the middle and the third gene. If you tally all of that up, 81.4 divided by 2 is 40.7. Non-recombinants, 40.7%, and another 40.7%. So all we need to do is figure out which are recombinants and non-recombinants. So where did we start? We started with black body, purple eyes, and vestigial wings. So we had a recessive fly crossed with the homozygous for gray body, red eyes, normal wings. So we have the F1 as the heterozygous, B plus, PR plus, VG plus, and then just B, PR, and VG. That was our female fly that was crossed with another recessive male. Non-recombinant, we would get 40.7%. Completely recessive, 40.7%. Who are our double crosses? We have heterozygous, homozygous, back to heterozygous. This would be our 0.2%. And another double crossover, homozygous, heterozygous, back to homozygous, 0.2%. And then we're going to go mix and match heterozygous versus homozygous. That is going to be 2.8% homozygous and then heterozygous, heterozygous. That's a 2.8%. And then the 6.3%, that was these. So I keep the first two the same and flip to homo here. Homo, that's a 6.3%. And homo, 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 hetero, another 6.3%. There you go. I hope this was helpful.